Hey guys, if you are getting this video, that means you're absent today, Monday, the 18th. And I just wanted to keep you guys caught up on some of the notes because what this week is going to look like is we're going to talk about, like you can see here, scientific notation. Basically, we're converting really, really big numbers or really, really small numbers into something that's more reasonable that we can actually do calculations with. We're going to use that in our acceleration due to gravity lab. And then we are also going to take kind of a very short test, call it a quest on Friday, that's going to ask you to do this. So I just wanted to make sure you guys have this in your notes because you can use your notes on the tests. So first thing I want you guys to do is write this into your notebook just like you see it here. Okay. So go ahead and pause the video and then write that in there. Okay, so scientific notation, all that does, like I said, is it allows us to easily represent really, really big or really, really small numbers. So go ahead and add this to that section in your notebook that gives us kind of the definition of what scientific notation is. Again, you can pause the video, write this in there, and we're going to talk about what this actually looks like. Okay, so when we use scientific notation, the reason is when we have a really big number like this, it's easy to accidentally type the wrong number of zeros, lose count, and it also just takes up a huge amount of space and time when we're typing this into a document or writing this on our notes. So we can use something like this to represent this number. These are the exact same. Another big reason, one of our goals today is to use scientific notation with calculations. A lot of calculators don't allow you to put this many zeros in. Okay, so if we know how to input scientific notation into our calculator, we can do these calculations with really big numbers and get our answer without being constrained to a certain number of zeros. Okay, so what this is really saying is we're taking this number, we're just going to kind of get rid of all these zeros and represent all those zeros with this 10 to the 15th power, right? So what that's really saying is if we did 10 times 10 times 10 times 10 times 10 times 10, 15 times, that's going to give us this correct number of zeros, right? The 15th power. It's going to move that decimal that many places. Okay, so let's look at what this looks like. Okay, so we are going to move our decimal, and we want to move it to a place where this number that we end up with is less than 10. That's really the only rule. So we don't want to put a decimal right here, right? Because then our number, we're going to end up with 17 times 10, right? And so we don't want this. We want a number that's less than 10. Okay, so now that 15 is simply just the number of places that we moved our decimal, okay? And that's really all it is we're just moving the decimal, okay? So pause the video, write this down in your notes real quick, and then we're going to show you how to do that, okay? So now, when we look at this number, how do we do this? Okay, so again, we want to move that decimal here, and we're just going to simply say, okay, this is where our decimal is. If we don't see our decimal, we just assume it's here at the end. Okay, we need to move that decimal. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 places. Okay, so when we rewrite that, we can get rid of all these zeros, right? And we simply wind up with 1.7 times 10 to the 15th. Okay, now remember when we looked at our data table over here, right? So the really, really big numbers, I want you to write that into your notes, show you moving that decimal on this really big side, and that's going to be a positive exponent. Okay, so go ahead and pause the video and go ahead and do that. Now, what happens if it's a really, really small number, okay, like a decimal? We're going to do the exact same thing. We're going to move that decimal place. Now, again, the number that we end up with over here, we need that to be less than 10, but we want it to be bigger than 1 or bigger, right? So we don't want to put our decimal here, right? That's going to make it 0.48. That's too small. We don't want to put it here. that's going to make it 48. That's too big. Okay, so we don't want our decimal there. So when we move our decimal, again, we want that number to be less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so we're going to end up with a number 4.8. This is really hard to write with this. Times 10 to the 11th. Now, on that table in your notes, right, we're moving that decimal to the right. That means that our exponent is going to be negative. That's very, very important, okay? So it's going to be to the negative 11th power, okay? And that's how we do very, very small numbers, so the exact same. So go ahead and pause the video, write that in your notes under that data table where it says very, very small numbers, okay? Now, if you want, go ahead and practice these. Obviously, you guys, if you're at home, you can't use chalk on your tables there, but go ahead and convert these numbers into scientific notation. So again, just count how many times you move the decimal. We should end up with something like 2.3 times 10 to the, I think it's ninth. So go ahead and practice those, okay? Pause the video if you need to. Now, the next step that we did is we talked about how do we enter these into our calculator. And guys, it's super, super simple. Just put it in parentheses, okay? So we have the scientific notation number here, right? We did all the work, we counted, we moved our decimal place, we come up with this number. Literally the only thing you have to do is make sure to include these parentheses, okay, as you put it into Desmos. That's the biggest thing, is put it in parentheses. That establishes our order of operations. Super, super simple. So let's look at what that looks like. Okay, so here's my Desmos. When I plug this in, I literally type it in exactly how I see it written with parentheses. So I go parentheses 1.7 times, I need my cursor, times, whoa, sorry, 1.7 times 10 to the, this is our to the power, arm button, to the 15th, and then we want to close those parentheses. Now, one thing to look for is if you just hit the parentheses button right now, it's going to put the parentheses up around the 15. We want to make sure it's big, right? So let's see what that looks like. Ooh, right? We don't want this, okay? We want to make sure, so all you have to do is hit the right arrow, and it drops this back down, and then when we put parentheses, it's saying, okay, that entire number, okay? Now, whatever operation we have, let's say we need to multiply it by 50, okay? Oopa, we can do that, okay? Now we have this big number in scientific notation times 50. There's our answer in scientific notation, okay? So it's very, very simple. So what I want you guys to do is practice with these, okay? So just put in parentheses around these. So we're saying this number subtracted by this number, okay? This number times this number divided by this number. Again, guys, it's super simple. Just put it in parentheses. So go ahead and pause the video and do that next piece. Okay, so now why are we doing this? Why are we looking at scientific notation? So when we talk about gravity, gravity is that pull that pulls everything towards the center of Earth or towards the center of any planet or object. But the cool thing is we also exert a force, right? We exert the same amount of force on the Earth. We exert a gravitational force on our coffee cup, on markers, whatever's around us, because we're going to find out with this next equation, all that this is really based on is the mass of the object. Okay, so we know all things have mass. If it's made up of atoms, it has mass. And depending on that mass, it's going to exert a certain amount of force. So more massive things like the Earth are going to exert a greater amount of force than small things like us, right? So that's why we don't see markers flying and sticking to us, okay? Because we have relatively a small amount of mass, okay? So now don't freak out when you see this equation. But I want you to write this into your notes. So this is how we do this, okay? So what this is saying is the force of gravity is equal to, this is our gravitational constant. Okay, so this never changes. So make sure you have that in your notes. Okay, so that never changes. That's our universal gravitational constant. Then we just take whatever two objects we're looking at, and we have the mass of that object in kilograms times the mass of the other object in kilograms. And then we're going to divide it by our distance squared. Now, this is very important. Everybody forgets this squared. So circle that in your notes, highlight it, whatever you need to do. Do not forget to square your distance. So let's put this, go ahead and pause the video, write that into your notes, and then let's practice this, okay? So when we look at, say we got two planets, okay? This planet over here has the mass of 4.7 times 10 to the 23rd kilograms of mass. This planet over here is a little bit smaller. It has 3.2 times 10 to the 23rd kilograms of mass, okay? And they are separated, the center of that planet, right? So it's going right from the center of the planet. Ooh, red doesn't work good on red. That distance is 4.0 times 10 to the 10th meters apart, okay? So literally all you have to do, like all our other equations, is you're just plugging this number in here for mass 1, plugging this number in here for mass 2, and then plugging this in for your distance. Okay, so that's where we're taking, okay, now we have that number in scientific notation. We simply make sure we have it in parentheses when we put it into our equation. And then we just calculate it, okay? It's pretty straightforward. Now, the big thing is we do want to make sure we include this parentheses here, because what that does is that's saying, okay, all of this inside those parentheses then is going to be divided by our distance squared, okay? So make sure we include all these parentheses. So practice that, try and put that into your calculator, see what you come up with, okay? Now, last piece, let's go. That's basically what we did today. So if you want to practice another one, you can do this with anything. So practice on this equation here. You can go ahead and pause the video, input those numbers, right? So here's our mass 1, mass 2, here's our distance. Don't forget to square your distance. And then there's one more practice problem if you want. This is a more realistic one. Okay, so this is kind of the step-by-step of everything that we learned today. So you should be able to convert each of these numbers into scientific notation. Then you're going to be able to plug that into that equation and show your work on this, because if you don't show your work, you're not sure where you're going to be able to make them, or you're not going to be able to see where you make a mistake if you do, okay? So give this a try. If you have questions, shoot me an email. All right, thanks guys.